Hello friends, welcome to IronHand Tech channel. In our developed world, we can easily take soap for granted. According to Accor, a hotel chain in Scandic, hotel guests only use 15% of the soap, shampoo, and conditioner found in their rooms, with the majority being discarded, some even unused. Approximately 26 million bars of soap are thrown away in the US, leading to an annual waste of 1 billion bars of soap. Considering that the US accounts for less than 30% of the 157 million hotel rooms worldwide, the global loss each year is staggering. Soap is made from a chain of molecules with two main halves. One end of the chain is hydrophobic, meaning it repels water, and lipophilic, meaning it is attracted to fats. The other end of the molecule is exactly the opposite, hydrophilic and repels fats. Put these two halves together, and you have one of humanity's greatest inventions: soap. Most people have the impression that soap sanitizes your hands by killing bacteria and viruses on your skin. However, this isn't entirely true. Germs and dirt cling to the oils and fats on your hands. Soap molecules then attach themselves to these oils and fats, and when you rinse your hands under water, they cling to the water molecules, pulling the oils off your skin and taking any bacteria they contain with them. In hotels, restaurants, and even in every household, thousands of tons of soap are discarded each year. These soap bars are often thrown away after just a few uses. But soap doesn't just disappear easily, it lasts for months in the environment, creating a burden on landfills and potentially polluting water sources if not properly treated. Meanwhile, in many parts of the world, millions of people lack basic sanitation, and soap becomes a luxury item. Waste and the lack of recycling exacerbate this issue. Recognizing this problem, Clean the World, a nonprofit organization, aims to recycle used soap into new bars of soap to distribute to those without access to it. Since then, this organization has distributed over 50 million bars of soap to 127 countries. Let's explore how used bars of soap are recycled. Everything begins with collection from sources like hotels and restaurants. These soap bars are gathered and sent to recycling factories. Here, the soap is thoroughly cleaned to remove impurities. After being sorted, the soap is fed into a grinder. This machine, equipped with high-speed rotating blades, cuts and grinds the soap bars into small, evenly sized pieces. Once the soap has been ground, it goes through a sterilization process. A common method is using heat. The soap fragments are heated at high temperatures for about an hour to kill bacteria and other pathogens. The soap mixture is compressed into molds under high pressure to form solid soap bars. After pressing, the soap is cooled and hardened before being removed from the mold. From used soap bars, we've created new ones. These products are not only visually appealing, but also as safe and effective as the original bars. Recycling soap isn't just about reducing waste. It's a humanitarian act that helps bring soap to those who need it most. These recycled soap bars are distributed to underprivileged communities, helping to improve sanitation and prevent disease. Today, some hotels are starting to adopt a different approach to minimize waste by completely removing single-use toiletries from their rooms. Instead, they offer bulk products. Clean the World recognizes that this is also a possibility for their hotel partners. The plan will be to create new impact products, such as hygiene kits and corporate event packages, to offset potential declines in production and revenue. Each recycled soap bar tells a story of hope, sharing, and responsibility towards our planet. By recycling soap, we're not just protecting the environment, we're bringing hope to millions of people around the world. Let's join hands to turn each old soap bar into a new opportunity for those who need it, with a simple act of leaving your toiletries in the hotel room instead of taking them home. Welcome back to IronHand Textile. The journey of an electrical wire doesn't end when it no longer serves its purpose. Within every old wire lies a valuable copper core, ready to be reborn for a new life cycle. Today, we'll explore how these seemingly useless wires are revived to become raw materials for countless new products. Every old electrical wire is like a carefully wrapped gift. On the outside is a thick protective plastic layer, and inside is the precious gift, copper. The first step in the recycling process is removing this outer layer, a task requiring precision, like peeling an apple without damaging the core. These old wires are fed into a shredding machine, where sharp blades spinning at high speed crush them into small pieces. The next task is to separate the copper from the mixture. A pneumatic separator takes on this role by blowing air through the wire scraps in a chamber. The strong airflow blows the lighter plastic or rubber insulation away from the copper, which is heavier and falls to the bottom. But the process isn't over yet. To achieve pure copper, we need another step. The copper is passed through a magnetic separator, which captures metallic impurities while leaving the copper untouched. After this step, we have pure copper ready for the melting process. In the furnace, copper endures temperatures of up to 1200 degrees Celsius, a harsh environment that removes impurities and allows the copper to be reborn in its purest form. The copper melting process takes place in large industrial furnaces where the copper is liquefied. In this high-temperature environment, lighter impurities float to the surface and are removed, ensuring that the final product reaches the required purity. The furnace is the heart of the metal recycling process. It uses gas or electricity to generate the high temperatures needed to melt the copper evenly. This process doesn't happen quickly, but it is sure copper needs time to shed its impurities and reach its purest state. After the copper has been refined and purified, the next step is casting. The molten copper is poured into heat-resistant molds, where it quickly cools and hardens into copper ingots. The rolling process begins with hot rolling. Copper ingots are passed through hot rolling mills to thin them down and reduce their size. Hot rolling reduces the thickness of the copper without losing its mechanical properties. The rolling mill consists of two large steel rollers rotating in opposite directions. As the copper ingot is fed between these rollers under extreme pressure, it gradually thins out, much like flattening dough with a rolling pin. This process is called hot rolling because the copper is heated red hot during the process. After hot rolling, the copper is transferred to cold rolling. Cold rolling helps thin the copper sheets to precise thickness and improves the material's hardness. Cold rolling takes place at room temperature and shapes the copper into thinner sheets with exact thickness. This is the final step to prepare the copper for other applications. To turn the copper into wires, a wire drawing machine is used. The machine features a special die with multiple circular holes that gradually decrease in size. The copper ingot is pulled through these holes, similar to threading a string through a needle. With each pull, the copper's diameter shrinks until it reaches the desired size. The rolling and wire drawing process not only prepares the copper for industrial use, but also ensures that the final product is of high quality and precision. After being drawn into wires, the copper wire is dipped into a chemical solution to clean the surface, removing any oxides and impurities. The wire is then dried and finally coiled into spools of various sizes for ease of transportation and use. Recycled copper helps reduce the need for new mining, protecting mining areas and minimizing environmental degradation. According to statistics, the copper recycling process uses 85% less energy than producing copper from new ore. Once the recycling process is complete, copper is no longer raw material, but an essential component for various industries. Thanks to its excellent electrical conductivity, high durability, and malleability, recycled copper is used in numerous applications, from electrical wires and car parts to complex electronic products. If every copper particle could tell a story, it would narrate a thrilling adventure, from being buried deep in the earth to becoming an electrical wire, experiencing aging, and being discarded. But the journey doesn't end there. Copper, like a warrior, never gives up, ready to return from waste to continue serving humanity. Like reforging an old sword to make it sharper and stronger. Recycling copper is not just about reuse. It's a transformation of seemingly useless things into brand new, stronger, shinier materials, ready for a new journey. Copper is one of the few metals that can be recycled indefinitely without losing quality. This makes copper the ageless friend in the world of resources, always ready to be reborn and serve new purposes. While other materials may degrade after several recycling cycles, copper retains all of its physical and chemical properties. This makes copper a valuable resource, not only for today, but for the future as well. No matter how many life cycles it goes through, copper always retains its strength and unlimited ability to serve. Recycling copper from old electrical wires is a clear demonstration of the power of technology and environmental awareness. Every recycled copper wire represents a long journey from waste to becoming a vital part of modern industries. But more importantly, it's a reflection of collective efforts to protect natural resources and reduce the negative impact on our planet. Every old wire you discard isn't just trash, it's an opportunity to regenerate a valuable resource. Let's recycle together for a more sustainable and brighter future. With copper, the life cycle never ends. It just starts anew, stronger, and more resilient. Thank you for watching. Hello everyone, and welcome to IronHand Tech. Today we're diving into a fascinating and crucial journey in the battle against waste, recycling old fabrics. But before we get into the nitty-gritty of each stage, let's take a quick look at some eye-opening numbers to understand the current situation better. Every year, around 92 million tons of textile waste are dumped into the environment globally. That's equivalent to a truckload of old clothes being discarded every second. And here's the kicker. Most of it will never fully decompose, especially synthetic fabrics like polyester. Those old shirts we forget about could outlive an entire generation. Textile waste doesn't just take up space in landfills, it also significantly contributes to environmental pollution, from contaminating the soil to polluting groundwater and even the air. According to a report by the U.S. Environmental Protection Agency, EPA, an estimated 11.3 million tons of textile waste ended up in landfills in the United States in 2018 alone, making up 7.7% of all municipal solid waste. Meanwhile, a report by the World Bank shows that the textile and fashion industry is responsible for around 20% of global industrial water pollution. The production of new fabrics also consumes a vast amount of resources, such as thousands of liters of water to produce just one cotton shirt, not to mention the energy and chemicals involved. So what is fabric recycling? Simply put, it's the process of turning old, outdated, or damaged clothing into new products, or, at the very least, recycling materials to be used in other industries. Fabric recycling not only helps reduce waste, but also saves resources and minimizes environmental impact. In today's video, we'll go through the entire process, from collecting old clothes, through processing, to transforming them into new products. And most importantly, we'll explore the modern machinery used in each stage and why they're so vital. Get ready to discover a world we rarely see, but one that plays a crucial role in our everyday lives. The first step in the fabric recycling journey is collection. Have you ever wondered where all those old shirts and ripped jeans go when we no longer need them? Don't worry, not all of them end up in the landfill. Old clothes are collected from various sources: households, fashion stores, and charitable organizations. Some people choose to donate their old clothes to those in need, while others drop them into recycling bins scattered throughout cities. There are even regular clothing collection events to encourage people to participate. Once collected, the clothes are sent to sorting facilities. This is a critical step in the recycling process. Here, the clothes are sorted based on material, color, and condition. Fabrics like cotton, polyester, wool, and silk are separated because each type requires a different recycling process. To do this, both modern technology and human labor are used. Optical scanners and sensors are among the key tools that help automatically sort items based on color and material. These scanners can detect and sort thousands of items in just minutes, a task nearly impossible if done manually. However, in many cases, manual sorting is still necessary, especially for complex fabrics or items with multiple layers of different materials. Why is such detailed sorting necessary? Because each type of fabric undergoes a different recycling process, and accurate sorting optimizes this process. If a polyester shirt is mixed with a pile of cotton, the recycling process will face difficulties, leading to lower quality or even unusable final products. Sorting is not just a preparatory step, it's a decisive factor in the success of the entire recycling process. After sorting, the clothes undergo pre-processing before being recycled. You can imagine that old clothes aren't always clean and ready to be recycled immediately. They need to be cleaned and have any unwanted parts removed. The first step is cleaning. This isn't as simple as doing laundry at home. It's a complex industrial process. Industrial washing machines are designed to handle large volumes of clothing at once, using strong water pressure and specialized detergents to remove dirt, grease, and other contaminants. Some modern technologies even use biological enzymes to break down organic stains, making the cleaning process more efficient without needing excessive chemicals. Next is the removal of unwanted components like buttons, zippers, and other metal accessories. This step is crucial because if these parts remain during recycling, they could damage the machinery or reduce the quality of the final product. After pre-processing, the old fabric is ready for the fiber processing stage. This is where your old clothes start to transform into new materials. The first step is shredding. The old fabric is fed into an industrial shredder, where it's torn into small fibers. This shredder is like a giant metal monster with sharp blades spinning at high speeds, tearing everything into fibers. These fibers are then separated by material using a fiber separator, which helps accurately classify the fibers so they can be easily recycled into new products. The fiber separator is one of the essential tools in this process. It helps separate different types of fibers without damaging their structure. This process requires high precision and speed because time is a critical factor in industrial production. Once separated, the recycled fibers are moved to the next stage of fiber processing. Here, the small fibers are combined to create new threads through a spinning machine. This machine is similar to a weaving machine, but with much greater capacity, capable of spinning thousands of meters of thread in an hour. This process requires a perfect balance between speed and durability, as if the fibers are spun too quickly, they'll break, but if too slowly, the process won't be efficient. Spinning machines are designed to ensure that each thread produced is of consistent quality and strong enough to be used in new products. However, processing recycled fibers isn't always straightforward. Some fibers, like polyester, need to be melted before they can be spun into new threads. The melting machine operates at very high temperatures, liquefying the polyester fibers before molding them into new threads. After being processed into new threads, we move on to the weaving stage. This is where the recycled threads are turned into new fabric sheets, ready for various applications. The industrial weaving machine is the heart of this stage. With modern weaving machines, thousands of threads are connected and woven into large sheets of fabric in just a few hours. These machines can weave at incredible speeds, but without sacrificing precision. Every thread, every stitch is carefully calculated to ensure the final product's quality. Once the fabric sheet is woven, it goes through the finishing stage. This stage includes several smaller steps, from cutting, sewing, dyeing, to the final quality check. Automatic cutting machines help cut the fabric into smaller pieces, ready for the sewing or further processing steps. Dyeing is also an essential process. The dyeing machine uses special dyes to create fabrics with bright and durable colors. This not only makes the recycled fabric more attractive, but also makes it suitable for various applications, from fashion to industry. So after all these complex steps, what can recycled fabric be used for? The answer is a lot of things. Recycled fabric can be used to produce new clothing, textile products, carpets, insulation materials, and even in construction. With each sheet of recycled fabric, we not only reduce waste, but also save resources and energy compared to producing new fabric from raw materials. Moreover, with technological advancements, recycling old fabric is becoming more efficient and environmentally friendly. Research is focusing on developing enzymes and bacteria that can quickly and safely decompose fabric, opening the door to new recycling methods. The future of fabric recycling is bright. With efforts from scientists, engineers, and even consumers, we can hope for a world where old clothes are no longer a burden on the environment, but a valuable resource that drives the circular economy and protects our green planet. Hello everyone, welcome to IronHand Tech. Today we will explore a very interesting recycling process at a local factory. Think back to the last time you threw away a pair of slippers. Do you remember what they looked like? You might find them in today's video. We're at a local recycling plant. There are a lot of old shoes being collected here, all ready for the recycling process. First, these slippers are crushed into small particles to create raw materials for the recycling process. Most slippers are usually made of plastic, so they can be completely recycled to create new products. Did you know that every year an estimated 20 billion pairs of shoes are produced worldwide, of which sandals make up a large portion? However, due to their short life cycle and rapidly changing fashion trends, a large number of sandals are discarded after a short period of use. The amount of sandals discarded each year could be enough to cover an area as large as the Amazon rainforest. They are one of the most common types of plastic waste globally. The plastic pellets are bagged and transported to another area where they are recycled again. The plastic pellets are fed into a melter where heating elements melt the plastic pellets to the appropriate temperature of up to 300 degrees Celsius. We have a lot of shoe uppers here, which are part of this recycling process. These shoe uppers are fixed into molds before being molded into the soles. The molds are made of steel to withstand the high temperatures and pressures during the molding process. The molten plastic pellets are transferred to the injection chamber by a screw. This screw rotates and moves forward, pushing the liquid plastic towards the mold. The liquid plastic is injected into the mold with the shape of the shoe sole through a nozzle. The liquid plastic is injected into the mold with high pressure to ensure that the plastic fills the entire mold cavity, creating the exact shape of the shoe sole. After cooling, we have a finished pair of shoes. The final job is to cut off the excess plastic, add the inner sole, package, and send these shoes to the place of consumption. You see, your discarded slippers have now been reborn as a new pair of shoes. Thank you for joining me on this journey. If you find the video useful, don't forget to like, share, and subscribe to the channel so you don't miss any interesting videos. See you in the next videos.